In this section, we're studying antiderivatives as areas. And the idea here is that we're studying the accumulation of units as the input variable increases. So what does that mean exactly? What do we mean by accumulation of units as input variable increases? Well, let's suppose a car is traveling at a constant velocity of 60 miles per hour. So the input here is hours, and the accumulation of units refers to the accumulation of miles. So for example, traveling at 60 miles per hour, after 1 hour the car has traveled 60 miles. After 2 hours the car has traveled 120 miles, and so forth. So the car is accumulating miles as our input, and in this case as our hours increase. We can view this accumulation graphically, and we're going to see that here in some examples. In this first example, it cost Rocking Rolls Bakery 85 cents to produce 1 dozen cinnamon rolls. Find the total cost of producing 10 dozen cinnamon rolls and sketch a graph illustrating the total cost as an area. So in this example, notice that the accumulation of units refers to the accumulation of cost. As our number of cinnamon rolls increases, as the production number increases, we expect that the total cost of production to accumulate. So we're told that the cost is 85 cents to produce 1 dozen. We can think of 85 cents as the derivative or the marginal cost. So if we use C to represent cost, then C prime of x, the marginal cost, or the derivative of the cost function, is equal to 85 cents. So then that means that C of x then, taking the antiderivative of a constant function, would mean that the cost function is 85 or 0.85 times x. So what we want to do is we want to sketch a graph illustrating the total cost as an area. Well, we can do that by graphing the derivative, which is 0.85. So if I graph the derivative here, that's just going to be a horizontal line at 0.85. And then we want to find the total cost of producing 10 dozen cinnamon rolls. So out here at 10, along the x-axis, if we think about the area that's formed by the cost function for 10 dozen cinnamon rolls, it's going to create a rectangle. So what we want to do is we want to find the area of this rectangle. And here, keeping in mind, our variable x represents the number of rolls being produced in dozens, and then our variable is c prime of x, which represents the cost. So here, if we want to calculate the area of this rectangle, recall area of a rectangle is given by base times height. So we need to find base times height. Well, in this case, the base is 10, and then the height of the rectangle is 0.85. So the area then is going to be 8.5. And here the units is going to be dollars. So it's $8.50 is the total cost of producing 10 dozen cinnamon rolls. In the next example, we have a toy boat moves with a velocity of v of t equal to 1/2 t, where t is in minutes and v of t is in feet per minute. We want to know how far does the boat travel during the first 30 minutes. So we're given the velocity function, which we can think of as the derivative of the position function. So if we graph this derivative, graph the velocity function, then we can answer this question by finding the area under the graph of the derivative function. So let's graph the velocity function. Here our variable is t, so t is the variable along the x-axis, and then our output is our function v of t, which will go along the y-axis. So if we think of this velocity function as an equation here, a linear equation, it has y-intercept of 0, 0, and then a slope, we have a slope of 1/2. So if we were to go up 5, and then we'd be over 10. Up 5, over 10. So there's what our line would look like. So we've graphed our velocity function, and we want to know how far the boat has traveled during the first 30 minutes. So during the first 30 minutes, that would be represented by the area under this velocity function up until t equal to 30. Now when t equals 30, then our velocity is 1/2 times 30, which is 15. So the point 30, 15 is a point on the velocity function, and we can use that to help us calculate the area of that triangle that is formed. So in calculating the area of the triangle that is formed, recall that the area of a triangle is 1/2 base times height. Here in this case, our base is equal to 30. So this distance along the bottom of this triangle here equals 30. So we have 1/2 times 30, and then times the height of the triangle. Well, if we look here, the height of this triangle is this distance along here, which we know is 15 based on this point here along the y-axis. So our height is then 15. So 1/2 times 30 times 15 is going to give us 225. So the boat has traveled 225 feet in the first 30 minutes. For part B, we want to know how far the boat has traveled between the first hour and the second hour. So once again, we're going to graph our velocity function, keeping in mind that our variable along the x-axis is t, time in minutes, and then along our y-axis is our velocity function given that gives us feet per minute. So here our first hour, which would be 60 minutes, we want to know how far it's traveled between 60 minutes and then the second hour, which is 120 minutes. So we want to know the area of that figure there between the 60 minutes and the 120 minutes. We'll define the area of that figure, recognize that it is a trapezoid, and to find that area we can divide it into a rectangle and a triangle, and then add those two areas together. So let's first calculate the area of the rectangle. So the area of the rectangle is going to be base times height. The base of this rectangle here, from 60 to 120, that distance would be 60. So we have a base of 60, and then times the height. Well, the height of this rectangle here is this distance here. So it is whatever that point is on the velocity function. Well, when t equals 60, our velocity is 1/2 times 60, so it's going to be 30. So the height of our rectangle is 30, plus the area of the triangle. The area of a triangle is 1/2 base times height. So we need to figure out what the base of the triangle is. Well, let's notice here that this distance, the base of the triangle, that distance here is the same as the base of the rectangle, from 60 to 120. So that is going to be a base of 60. And then times the height of the triangle. So the height of this triangle here is going to be from this point to this point. Well, we said that this point is 30 along the y-axis. So now we need to know what this point is here. Well, we can find it by taking the velocity when time t is equal to 120. And half of 120, 1/2 times 120 is 60. So that point there on the velocity function is equal to 60. So now to find the height of this triangle here, we can find that height by taking 60 minus 30. 60 minus 30 is going to give us 30 for the height of the triangle. So now simplifying, we're going to have 1800 plus 900 when we do 1/2 of 60 times 30 to give us a total of 2700. And here we're talking about feet. So the boat traveled 2,700 feet between the first and second hour. For number 3, Redline Roasting has found that its marginal cost in dollars per pound is given by C prime of x equal to a negative 0.012x plus 6.5, and that's for x less than or equal to 300, where x is the number of pounds of coffee roasted, and we want to find the total cost of roasting 200 pounds of coffee. Once again, we can answer this problem by first graphing the derivative and then calculating the area under the curve or under the graph of the derivative over the interval 0 to 200 to find the total cost of roasting 200 pounds of coffee. So when we graph this, our variable x along the x-axis represents the number of pounds of coffee roasted, and then along our y-axis is the derivative c prime of x. Now when we graph this function, notice that we have a y-intercept of 6.5. So we cross the y-axis at 6.5, and then we have a negative slope. So the graph is going to look something like this. And we are interested in calculating the area over the interval 0 to 200. And that'll give us the total cost. So in calculating the area of this figure, notice we have a trapezoid, so we can break this up into a triangle and a rectangle to calculate the area and add those two areas together. Well, in calculating the area of the rectangle and the triangle, we need to know what this point is right here. So this is when x is equal to 200, c prime of x. If we plug 200 into the derivative function, what we get is 4.1. So that tells us what this is along the y-axis, which is 4.1. So that gives us the height of the rectangle. So when we go to calculate the area of the rectangle now, area of a rectangle is base times height. So the base of this rectangle here is 200. So we have 200 times the height of the rectangle. And the height of this rectangle here is going to be 4.1. Plus the area of the rectangle. Well, area of a triangle. The area of a triangle is 1/2 base times height. Well, the base of this triangle here is also 200. So we have 1/2 times 200 and now times the height of the triangle. So the height of the triangle here is given by this difference here. It's the difference between 6.5 and 4.1, which that difference is 2.4. So the height of the triangle is 2.4. Alright, and then when we simplify this, we get 1,060, and then we're talking total cost in dollars. So the total cost of roasting 200 pounds of coffee turns out to be $1,060.